on to some relational queries. So the first query is list all the unique union membership numbers from the table employed. So here is the query result. We'll be using the operator project on union membership number from the table employed. The next query is fetch the details of technician whose names end with A. So again we'll be using the query. Here we will be using the select operator. Name like %sign A. Here the % indicates that we do not know the specific number of characters that occur before A in the names of technician. So here is the table technician. List the details of all the employee whose name is Akash. So here we will be selecting the technician whose name is Akash by projecting on SSN, name and salary. So these details will get displayed. Find the number of models that have gone through the FOI test. Here the result will show out. We'll be using the project operator on model number, and then this function, this is called aggregate count. It will count all the model numbers who have gone through the test whose name is FOI.
Discussing about normalization. So normalization is the process of reorganizing data efficiently in a database so that it meets two basic requirements. First is to eliminate redundant data, and second is to ensure data dependencies, that is, only related data is stored in the table. Now these are the various normal forms of database: first normal form, second normal form, third normal form, Boyce Codd normal form, and fourth normal form. The first normal form simply says that each cell of a table should contain exactly one value, that is, it should not be multi-valued and they should be unique. Here in table technician, we have phone number and address as multi-valued columns. So to bring the table to first normal form, we split the table into two tables, and now we have these resulting tables.
Moving forward towards the second normal form, our tables will be in the second normal form if it will satisfy these two conditions. That is, it should be in the first normal form that we have done previously. Secondly, there shouldn't be any partial dependency. This condition occurs when we have composite keys, that is more than one primary key. Every non-prime attributes are the attributes that are not the primary keys. So every non-prime attribute must be dependent on the table's primary key. As in our relation, we have only one primary key and all the non-prime attributes depend on that primary key only. So our relation is already in the second normal form.
Moving to 3NF, it says the table should follow these two rules. Firstly, the table should be in 2NF, which we have already seen. Secondly, the table should not have transitive dependency for non-prime key attributes. That is, a relation should not have a non-prime key attribute determined by another non-prime key attribute or set of non-prime key attributes. In our relation, table model has one prime key attribute model number and two non-prime key attributes capacity and weight. The non-prime key attribute weight is functionally determined by the non-prime key attribute capacity, which is the violation of 3NF. So we'll break the table and we'll take the transitive part, that is the weight attribute, and we'll put it with capacity in another table, which will solve our problem. That's all for the video. Thanks for watching.